and then I share my screen. And now anything that's on my computer is on the TV, but it's also being recorded in the Zoom. So like if you were to go home tonight and rewatch this video, then you would hear all this nonsense right now. It would be like the beginning of the video. So when you watch my videos, you're not going to see my face except for maybe a couple seconds at the beginning. It's going to be, if you've ever watched like a Khan Academy video, it's that same idea. No one wants to see Sal Khan's face. It's about watching the writing and listening to the words. So someone asked earlier, would you record this, or are you going to put this on Canvas? And I thought, yeah, I hadn't really planned on it, but sure. So before we begin, just to be clear on perspective, your scores were really, really low. Not everybody, but generally. And so what we want to do is focus not on boo-hoo, I'm so dumb, because that's not the case. We want to focus on, I'm not happy with the score. I'm quite frankly a little bit mad about it, and I want to learn and get better. That has to be the approach. All right. So I'll run through the problems with you. Your input is totally welcome. I love it when you guys talk. This is not a have to raise your hand kind of class. I know that you're more maybe comfortable with that, but I'm okay if you just blurt out some stuff, as long as it's not the same person all the time, taking all the answers. But you say what you got to say. So right away, and again, I don't want anyone to feel embarrassed, so you say what you want to say. But the first problem that we see is -4 plus 7. So the first thing my brain does when I see this is I say that answer has to be positive. Why do I know that? Because the bigger number is positive. And if 4 negatives and 7 positives get in a fight, the positives will win. And how many of their soldiers will be left standing? 3. There's nothing else that could possibly make sense other than an answer of +3. If that's more thinking than you'd care to do, you can also think of a number line. And I tend to draw my number lines vertically, for the record. And I always want 0 because he's the great divider. He separates negative land from positive land. So if you wanted to model what this looks like, you could start down here at -4. And this right here, I'm going to put a yellow box around it. This is actually a verb. That's an action. What does +7 mean to do? Not literally. On my number line, what does it mean to do? Up 7, I heard somebody say. Listen, you got to understand in your brain that plus means we're going up. When the temperature goes plus, it gets warmer, right? And so if I add 7 and I move from my location of -4 and I go up 1, 2, 3, 4, I've broken even, but I've still got 3 more to go. 5, 6, 7. If you haven't established, if you're not at a point in your life where you've learned to feel that way about numbers, let yourself start to feel that balance of 0. Did I cross 0? Am I negative? Am I positive? Right? The next question is 3 minus 12. What's the first thing I have to know about 3 minus 12? Say it again. Yeah. So overall, what is my answer? Come hell or high water, what does my answer have to be? Negative. If you can get that much, I am proud, and I can work with whatever other mistakes are coming. What I can't work with is if you don't say negative. I cannot work with the idea that you possibly would think that 3 can have 12 taken away from it and still have leftovers. I can't do that. So the first thing I do if I'm doing this math problem, like Alon said, is the 12 is bigger. And so if I got 3 and I'm taking away 12, that's negative. Now I go to the math. And people have different tricks. Like Katie might have learned it as I take the 12 and I subtract the 3. Some people might do it very visually on the number line. I don't really care. If you start at 3 and go down 12, how far do you go past 0? 9. So it's -9. Getting the negative out of the way is the key. And then you can do the math afterwards. Question number 3. Oh, I just spilled some coffee. Oh, boogers. Question number 3 says 6 minus -2. What were you taught to do when a minus and a negative follow each other like that? Change them to a plus sign, right? And so what happens is the minus and the negative. So the minus, here's my pens. I can't show this on the video, but like my minus sits here and my negative turns sideways and goes like this. And you're like, bam, look at us. We're a pretty good team. We just made a plus sign. So this problem really says 6 plus 2, which is of course 8. I'll stop periodically and ask if you have questions. So here it goes. Any questions so far? All right, let's head on. Number 4 is really just a different starting point, but it attacks the same idea as number 3, and that is that I spy with my little eye a minus and a negative touching butts. And those are the ones you got to watch out for. That negative out in front of the 12, don't worry about that. I'm worried about the ones that are together. And what happens again is they make a plus. So they both go away, and in their stead sits a plus sign. And now we go back to the fundamentals. What did your brain tell you first off about this answer? What does it have to be? It has to be negative because there's more negatives than positives when we add them together. The balance of it says so. How many more are there of the negatives? So the answer is -4. Listen, when you sit here and talk to me about it and you look down at your paper and you're one of the people in this room right now that put -20 for that answer, it's okay to feel a little bit like bad about that. Like, what was I thinking? When you start to understand how numbers work, you realize how weird that answer is in this sense, right? Ups and downs, baby, ups and downs. Number 5 exists for a very, very, very particular reason. And for me, I don't much talk about this. And I stopped about 20 years ago. It's like 10 years into my career. I just said, I don't want to do this anymore. Because what I found happening is that a lot of people think that addition comes before subtraction and that multiplication comes before division. And it's not true. And that's why problem 5 exists, is when I put 9 minus 5 plus 7, you don't have to raise your hand and volunteer this, but if you put -3, you better listen carefully. That means that you fell for the order of operations thing. What goes first in this problem? The minus does. Why? Because it's first. Plus and minus are on the same level. Some dude over there said that earlier. I think it was like Case, and he said they're on the same level. Now, that's a perfect way to say that. Neither one trumps the other one. 9 minus 5 right here is 4, and 4 plus 7 is 11. When they're equally powerful, you just read it like a book. Number 6, if you write it out correctly, is actually just -11 plus 2 minus 15. And then here it comes again. Think of it however you want to think of it. I like to think about a number line. And I think, okay, if I start down at -11 and I go plus 2, where am I? -9. But then I dip down and go minus 15 more. Where am I? -24. If you learn one thing from me this year, let it be the importance of mathematical literacy. I can reteach you slopes and systems and all that other stuff some other time. If you walk away from this year and you feel like you're more understanding of just how numbers make sense, I'll consider that a good year. Ups and downs on the number line, sensible answers. Number 7, we get into your times tables. When people tell me that they, quote, struggle with their times tables, here's what I hear. I have chosen to not learn my times tables. It literally translates into my head when you say that. Oh, I suck at times tables. I hear, I'm too lazy to learn my times tables. I refuse to accept the fact that there's a single person in this room who cannot learn their times tables. What's this? Cup, mug? What's this stuff? What's this? What's this? What's that thing on Kane's head? Okay, what's this? Oh, what are these? What's that round thing on the wall? What's this? No, it's not. It's 63. And I will take this and fight this. In my 28 years of teaching, I have met 2 kids that were physiologically unable to memorize times tables. They both had things going on with their physical structure of their brains that prevented them from retaining times tables. I've met over 3,000 kids in my career, and I've only met 2 where I said, please use a calculator for everything. If you tell me that you struggle with your times tables, I'm not going to hear it. I'm not going to feel any pain about it. I'm going to tell you, get off your butt and go learn them. because your third grade teacher tried, your fourth grade teacher tried, your fifth grade teacher tried. There comes a point where you take it on yourself and download an app on your phone that makes it less boring, and you buckle up and say, I'm going to learn these things. You say, I want to get so good at my times tables that if my teacher says 8 times 7, you're already saying 56 before I can finish pronouncing the 7. In the same way that when I pointed to that round thing on the wall, you didn't have to do a calculation. When I held this up, you didn't have to analyze it. You just know it's a pencil. When I write this, you don't analyze it. You instantly think 63. And it happens like that. Every math class you ever take, you'll be more successful if you're more literate. And part of that is quick, fluent resuscitation. Is that the right word? Recitation of your times tables. Boom, boom, boom. So anyways, number 7 is 56, 8 times 7. Number 8 exists because I want to make sure you know that a negative times a positive is another negative, right? So that's negative 36. It's still just times tables. You got to know whether to put a negative or a positive. Number 9, what's a negative when you divide it by another negative? Positive 7 there. And then number 10, what's a negative divided by a positive? Another negative. In that case, 9. So negative 9. There's a couple things I can show you. Number 1, here's the way that my brain does it. If I see two numbers that have the same sign, meaning a positive times a positive or a negative times a negative, what is the answer always going to be? That's how I think of it. And of course, on the other side of that, then, if I see two numbers that have different signs, that means either a positive times a negative or a negative times a positive. What does the answer have to be? And if you need one more way to memorize your rules, it goes like this. When good things happen to good people, that's good, right? Right. Like your best friend wins the lottery. That's good. When good things happen to bad people, child molester wins the lottery. Can we agree? That's bad. When bad things happen to good people, that's bad. That's best friend getting the flu, or grandfather that you dearly love getting cancer or something. This is bad stuff happening to good people. The net result of that is bad. And my personal favorite always, because I'm this way, is when bad things happen to bad people. What is that? Yeah, that's a win for the world, baby. Right? The example I use is sometimes a bit extreme, but I would say like the child molester. You remember him from example 2, getting run over by a bus? Hey, listen, that's a bad person, and that's a bad thing. Good results. So there you go. Don't ever mess up your rules of multiplication and division. The easiest way to memorize it is what I have written here in red. Same, positive, different, negative. Next row is exponentiation. So the first problem says 8 squared. Can someone tell me what that means? 8 times 8, which is wonderful. The next question is negative 11 squared. And that means to take negative 11 and multiply him by himself. And that's a negative times a negative, which is a positive. And then I thank my teacher who made me learn this stuff. What's 11 times 11? The next problem is really an order of operations problem. And the reason it exists on this pretest is because I didn't want you to put this answer. If you put this answer, that's really bad. So I hope you didn't. When you see 4 times 3 squared, the order of operations demands of you that you do this first. What is 3 squared? So we do 4 times 9, which leads me now to the next problem. And I got a lot of questions about this one that, hey, I thought that should be a positive answer. The next question says not negative 10 squared. If it helps, listen carefully. What it says is the opposite of 10 squared. And so when I write this math problem, Pop quiz while I have a sip of coffee. What in this problem is being taken to the power of 2? Just the 10. The negative not being in parentheses is a really big deal. That means that only the 10 is being exponentiated like this. And what is 10 squared? That's 100. But then the negative's like, whoa, 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 don't forget about me. And then you stick it on at the end. The moral of the story there is that when the problem like that exists, you have no control or say. The negative is like, I'm just going to sit here. You do whatever you want. At the end, I'm coming down and sticking myself on your answer. Okay. The next row of problems is just more order of operations. So I'm going to mildly pick up the pace to make sure that I get through what I need to get through. So please stop me, though, if I go too fast and you have a question. Because again, you get to do this again on Thursday. So I want to see vast improvement. 100 minus 6 minus 3 is 3, like that. And I did that order of operations. I did the parentheses. What goes first on this next step? Exponent. 3 squared is 100 minus 9 is done, 91. The next question is exactly the same as question 5. And again, you can be your own judge of this. If you put 1 on this, that is the worst answer in the world. It means that you're in that mindset, that trap of thinking that because of PEMDAS that M comes before D. Not true. How do you do times and divide? Same level. So how do we attack them? Left to right, like a book. What is 24 divided by 3? And what is 8 times 8? There you go. I apologize for problem 17. I think I was temporarily abducted by aliens when I wrote this problem because it just really goes from like 0 to 100 real fast. 17 is a hard math problem, so you'll get no flack from me if you struggled with it. But let's run through it. You'll see. It's not bad. No, I can do this. If you got it right, by the way, good job. -5 minus 2 times or 3 times 2, which is 6. And then I'm going to put plus 2 times, and then I am going to go ahead and answer the parentheses. Don't you dare say 2. What's 4 minus 6? -2. So that's step 1, is to get rid of those parentheses. I know they're still there, but they're not really parentheses anymore. They're just enclosures, right? Different kind of thing. What goes next? Exponentiation, right? So this right here has to go next. So what is -2 to the 3rd power? It's -8. That's tricky because if you think about it, like these 2 negatives that I'm underlining, they make a +4. But then the other oddball guy comes in and says, I'm going to flip you back to negative. So -8. So I'm going to replace that big purple box with -8. So now it's -5 minus 6 plus 2 times -8. What goes next? Definitely the multiplication. This is your next priority. So what is 2 times -8? Yeah. And here we find ourselves again at a point where we say, what a shame that I can get this far and then miss it because I don't understand the number line. Inexcusable. The starting point of this problem is I'm already 5 below the 0. Where do I go? I go down 6 more. Where am I? I'm at down 11. That's minus or -11. And from there, where do I then go? Down 16 more, putting me way. If I'm 5 feet underwater and I swim down 6 more and then down 16 more, I am 27 feet underwater, -27. And let's talk about fractions. And then we probably won't have too much time to go much further than that, but that's okay. I don't mind going over some more of this stuff tomorrow, but I think I've already said this. Did you see my coffee? What I did? I did a boo-boo. This I'll teach you all again anyway, so I'm not too worried about that front page. But we'll go through this. All right, last row of problems. Tell me how much you love fractions. Oh, I'm sorry. I always say with fractions, like, you can hate them. Hate them all you want. but you have to learn to peacefully coexist with them. You're not going to get through high school math if you can't develop at least a relationship, a working relationship with them. What is wrong? Some of you know the answer to this and some of you don't. What is wrong with that problem? 12's what? It's a whole number. Why do you care? Right. So someone got paid to teach you this. That 12, first things first, needs to be written as a fraction so that he can play with the other one. Step one. Listen, you're not going to get in any trouble in a simple problem like this if you now just multiply straight across. What's 3 times 12? What's 4 times 1? What's 36 divided by 4? You're not going to get any flack from me if that's how you attack that problem. Now, the next problem, if you try that method, you're going to get a lot of flack from me. Did anyone in this room get 336 over 392? Did you leave it like that? Right. So to avoid that wrong answer ever happening in the future, let me show you how you should do problem number 19. First things first. Here's some good news. That's a fraction. And that's a fraction. Okay. But the problem is that division doesn't really exist. Math purists would tell you there's no such thing as 12 divided by 3. There is 12 times 1/3. Like 20 divided by 4 doesn't exist. It's 20 times 1/4. So again, division, some would say, is a fake thing. So how do I turn this into a problem that I can do? You've heard these words before. Copy, dot, flop. I don't care if you use those words. They're kind of dorky, but they're pretty cool because they help you remember the 3-step process for dividing fractions. Copy means this. Don't change the first fraction. What's the dot mean? Change it to multiply dot. The dot means multiply. So the dot is multiply. And what's flop? Switch your second fraction. Flop it over. So 8 and 21 switch places, giving us 21 and 8. Right? And if you want to find yourself in a position where you get really big numbers, then you will just multiply straight across. So let's not go that road. Instead, let's look for things that we can reduce right now. And this is, again, times tables coming back. What can 16 and 8, my yellow numbers, what can they both be divided by? 2 is fine, 4 is fine, but 8's the best. Go big, go big or go home. What is 8 divided by 8? 16 divided by 8. Progress already. Beautiful. Times tables again. You got to know them so you can see them. What do 21 and 49 both have as a division guy? Let's divide them both by 7. What's 21 divided by 7? What's 49 divided by 7? And this takes that really big fraction and reduces it before you ever have to see it in that big fraction state. So easy. And then you just multiply across. 2 times 3 is 7 times 1 is done. Okay. Are you guys still with me? Yeah. All right, let's do another math problem. Math's all about tricks, like knowing the first step. So what is the kicker when your math teacher gives you a problem with a plus and fractions? What's the trick? Yeah. Yes, you do. And it's not fair. Like with multiplying and dividing, I don't give a crap about the denominators. I just do my thing. With plus and minus, all I care about is the denominators. Completely different things. So now I got to get in there and say, okay, I can't add you guys together. You see that? Like if Kane buys a pizza and cuts it in 6 slices and eats 5, and I buy a pizza and cut it into 8 slices and eat 3, that's not a fair comparison situation. I need to know, what would it be if we both cut our pizzas the same way? What I'm trying clumsily to say is, what's the least common denominator of 6 and 8? It is 24. And listen, a lot of times people say 2, and you're thinking well, you're just thinking from the other perspective. When you think 2, you're thinking of what's the biggest number that can go into 6 and 8. And that's important, just not for this problem. What I'm asking you is instead take 6 and 8. What can you turn them both into? And that's what the 24 is. And then we just convert the tops to match the bottoms. On this one, we had to multiply by 4. 6 times 4, negative 5 times 4. On the bottom, 8 times 3, 3 times 3. And then you see what I mean now, right? Here we are doing math, but we're always coming back to the basics. We always seem to have to add and subtract with negatives. Can't get away. Add the yellow numbers. What's negative 20 plus 9? Negative 11. And then you just stick it over the same bottom and you're done. When I give you this test again on Thursday, the numbers will be different, obviously, but the problems, the situations that I'm addressing are going to be identical. There's going to be one of these. There's going to be a multiplier, a divider. There's going to be the ones where I test your order of operations. So please, I want to see improvement. And again, that doesn't mean everyone goes from the gutter to la la land. Like, I mean, I just want to see you putting forth the effort and getting better. And if you go from a minus 26 to like a minus 15, that's a win. And then I give you another one next week and you go to minus 11. That's a win. And then you're at minus 5. And eventually it might be Halloween. You got it down, right? All right. So tomorrow we'll finish going over this. And Thursday we'll take a retake. And then I think Monday we're going to start Algebra 1 course content. All right, then. And again, I will upload this, post it on Canvas. So if you want to get in and browse around a little bit and just see the first Canvas post and what it looks like, I would encourage that.